remember the issue with recursion. So, if you recall, when we have recursion, or when we make recursive calls, we are pushing things to something called the procedure call stack. Okay? And when we do that, those things that we're pushing are these things called activation records. So, when we push too many of these recursive calls, or these activation records, to the call stack without ever popping any of them, we blow up the stack and we get something called a Stack Overflow error. Okay? And that's not good. We don't want that. So remember that even tail recursive methods suffer from this problem. Remember, the idea behind tail recursion was maybe we can just reuse the existing stack frame because there's no other context outside of the recursive call. Well, unfortunately, Java doesn't do that. Java doesn't do this thing which is called tail call optimization, and because of that, we're kind of, well, it seems like we're out of luck. You know, we have this idea which was called tail recursion, and theoretically we could have used that to mitigate Stack Overflow errors, but what do we do now? The solution is something called a loop. So if you're coming from a non-functional programming language such as Python or even Java, then you probably are already familiar with loops. But the way that I teach them in this class is a little unorthodox. Some people think it's unnecessary, but I think it really helps. So, what's the idea here? Well, there is a one-to-one correspondence between tail recursion and loops. Okay, so what do I mean by that? I mean that when you have a tail recursive method, such as, let's consider the factr method. When we have a tail recursive method, we can mechanically transform this into an equivalent loop. And the nice thing about loops is that they do not use the call stack. Okay, so it's a little disingenuous to say that they don't use the call stack at all, because they certainly can. So inside of a loop, you might have something that you might have another method call inside of a loop, which of course uses the call stack, but the loop in and of itself does not make recursive calls. Okay, and because of that, the stack is not used, which means that there's no inherent possibility of a Stack Overflow error. And by inherent, I mean that you're not going to get a Stack Overflow just by using a loop in and of itself. There could be something inside the loop that causes the Stack Overflow error, but if the problem that you're getting with a Stack Overflow error is because that the previous method is tail recursive, then a loop will fix that. Okay? So the thing is, what is a loop? Well, in Java we have this thing called a while keyword. It takes in something called a predicate. And we talked about predicates before. Where have we seen that before? We've seen that with if P, then C, otherwise A. Okay? So that's where we've seen predicates before. Predicates are just conditions that return either true or false. Okay? So, a while loop says the following. While some condition P, while some predicate P is true, we're going to do some code. Okay? So while some condition is true, do some code. Alright? Now, like I said, there's a mechanical transformation process that we can take to convert any tail recursive function into an equivalent loop. And that's what's so nice about this, okay? We have these tail recursive methods that we've written. That's what we did last week. That's what we did in the previous section. Now, we can take those tail recursive methods and loopify them, so to speak, and convert them into methods that do not Stack Overflow.